All right, so yesterday we talked about differential equation and how we can graph its slope field. And then when you draw a curve through the slope field, that is the answer, or basically what happens when you actually do the integral. So that's how a curve will look like. Now today we're actually going to solve it. But we're only going to look at one kind of separable equations, and then later on, when you learn more calculus, you'll learn how to solve other kinds of equations. Okay, separable equations has to be in this form. Okay, so it has to be a first order. It doesn't really have to be first order, but you start from whatever order it is, you kind of integrate backwards. But a first order differential equation will be in this form. So for dy dx, it has to be a function of x times a function of y. In order for us to actually be able to solve it, dy dx has to be a function of x times a function of y. So last night's WSQ, the reason you cannot solve it is that it is a function of x plus a function of y. So when you're adding and subtracting, we cannot solve it with all the information that we have right now in this class. Later on, when you go to higher calculus, you can do it. Right now, we cannot. So it has to be something that's multiplied together. For example, if dy dx, so this is the first order differential equation, and we want to be able to solve it, then one of the function has to be in terms of x, the other function has to be in terms of y, and they are multiplied together. Okay, they're multiplied together. Now, if you want to solve this question, then what you want to do is you want to separate the equation. So this is called separable equation because we're going to solve it by separating the variables. So we're going to move all the y's on one side and all the x on the other side. So how do I get, so first thing is I'm going to get rid of that fraction. So you never thought that you could separate a derivative, but you can. So I'm multiplying dx on both sides, and then I move it over. Okay, so what I'm going to do is move all the y's to the dy's, and then all the x to the dx. Okay, so on the left-hand side, I have a dy. On the right-hand side, I have a g of x, f of y, and dx. Okay, so I want to get all the y's to the other side. So how do I move this f of y to the other side? Yeah, divide. So I am going to divide by f of y, and then dy is equal to g of x dx. So when we solve these kind of separable equations, we have to get all the x's on one side. All the x's on one side and all the y's on the other side by multiplying or dividing. If you need to add and subtract, you cannot solve it. Okay, and then at this point, once we separate them into two variables, we're going to integrate. So you basically integrate on both sides. And then on the left, you're going to get whatever that function is. On the right, you're going to get whatever that function is. Make sure you put a plus c. Okay, so this is how you separate. So you separate it based on x and y, and then you integrate both sides. All right, so let's go ahead and solve an actual problem. Solve the differential equation dy dx equals x squared y squared. All right, easy. So we're going to multiply both sides so that there is no denominator. Okay, so y squared dy is equal to x squared dx. I don't need to explain how I get that, right? You guys are good? Yeah, easy. Okay, and then once you have all the y's on one side, all the x on the other side, you're just going to integrate. Okay, the integral of y squared dy is y cubed over 3. And then the integral of x squared dx is x cubed over 3, and then we want to do a plus c. Okay, and the reason we're doing this is that y has some x in there. Kind of like when we did implicit differentiation, there was some x in y, and so then we're trying to separate it so then we can solve it. Good? Okay, now that's part A. Part B says, what if you have some initial condition, and that initial condition is y of 0 is 2. So when x is 0, y is 2. Then basically they want you to find c. Okay, so when x is 0, y is 2. How do we find c? Plug it in, yeah. All you do is just plug it in. Okay, y is 2, so that is 2 cubed over 3 equals x is 0, so 0 cubed over 3 plus c. So c is 8 over 3. All right, so then they want you to find the equation with this initial condition. Therefore, that is y cubed over 3 equals x cubed over 3 plus 8 over 3. Okay. Now, a lot of times, these kind of questions show up in multiple choice. So then they may not write in this form. They may want to write it in y equals. So if they do a y equals, you have to solve for y equals. Does that make sense? Okay, so if they have a y equals, then that's going to be y cubed equals x cubed plus 8, and then cube root that. So y is equal to cube root x cubed plus 8. Okay, so that answer may show up. Okay, so just letting you know. All right. Okay, the last thing I want you to do is just check on your calculator and see if you can actually see that solution. So you can actually graph both at the same time. One, graph the slope field. Second, graph this equation. See if they overlap, because they should. Right? Because this is a solution to that slope field, so you should see both equations. Anyways, so put that first equation in y1, and then do your slope field, and then put the second equation and graph it. All right, so on the homework, there are a few problems they want you to double check that your solution and the slope field actually match, so this is what you do. All right, let's have you guys try one.
Y squared or y?
Okay, dy dx is 3x squared y squared. All right, we want to separate the variables, so multiply both sides by dx first. And then we want to move the y squared over, so 1 over y squared dy is equal to 3x squared dx. Okay, at this time, they're all separated. You are going to take the integral. So the integral of 1 over y squared. 1 over y squared is y to the negative 2. So 1 degree higher is y to the negative 1. Okay, so that is negative 1, y to the negative 2. We don't want that negative in the front, so then we're going to multiply by negative 1. Okay, so this is negative y to the negative 1 equals to x cubed plus c. All right, if you wanted to change it into a proper form of y equals 2, first move the negative. And then you're going to just flip it. Okay, y to the negative 1 just means 1 over y. So if you want to flip the whole thing, you flip the entire thing. All right. Okay, so that is the solution. Let's try another one with sine and cosine. Try this one. All right, so this is going to be 2y plus cosine y dy is equal to 6x squared dx. And then take the integral. Now the integral of that part is okay. I mean, you can do it because it's a plus sign with both of them being y. So that's okay. So this is y squared plus sine y equals 2x squared plus c. Sorry, cube. Thank you. All right. Huh? Yeah. You cannot. Yeah, some of them you cannot. Yeah, just leave it like that.
Do we have to take it to each to y equals?
No, no. Just sometimes when you see a multiple choice, sometimes they'll have an answer in y equals, and then you want to be able to find the correct answer. But this one is too complicated, they won't write it in that form. Okay, try another one. This one. This one has an initial condition. All right, 1/2 e to the 2y is equal to, let me double check. Yeah, x squared plus 1/2. Okay, one more, and then I let you go ahead and do homework. Here. Let's try this one. dy dx is equal to negative e to the x y squared over 10. Okay, I have my answer in y equals 2, so it's y equals 10 over e to the x plus c. There are two negatives, so it ends up canceling.
The plus c.
Why is it plus? Okay, so let's separate the equations. 1 over y squared dy is equal to negative e to the x over 10 dx. So take the integral. This is going to be negative y to the negative 1 is equal to the same thing, negative e to the x over 10 plus c. Did you guys put minus c? Yeah, okay.
Oh.
So y to the negative 1 is equal to e to the x over 10 minus c, and then y is equal to 10 over, okay, I'm making this very complicated, e to the x minus 10c.
You have to put in c. Can you just
Yeah, so C is a very interesting thing. So what you want to do with C is just be careful, I guess. Like C is C, right? C is just a constant. It's just how you define this constant. However you do it, keep it constant. Oh, that's a pun. Not a pun. Anyways, just try to do this, be consistent with how you find C. As long as you can find the constant, whatever that number is, you don't have to put a 10 in front of it. You can just call this whole thing like, I don't know, Z or something, and then find Z. Yeah, so doesn't have to be minus 10C, doesn't have to be 10C. It could just be a number. You just have to find that number.
Pretty interesting.